It's a bit later than I expected it to be, though. So we're going to get straight into the second talk. Big round of applause, please, for Florian Sellmayr from ThoughtWorks.
All right, thanks for having me. I'm going to talk about something completely different, build pipelines. I guess we're mostly developers here, so most of you have probably heard that term before. We started some time ago, we started figuring out that maybe it would be a good idea to have a build server that can actually run our tests whenever we make a commit. And we got further and we said, now we want to have full-featured build pipelines that refine our code and build it and deploy it to wherever we want it to deploy. Well, here's a thought for you. The builds we're using for that suck. Jenkins sucks. GoCD sucks. TeamCity sucks. I'm Florian. I am a consultant with ThoughtWorks, and I'm the author of a little open source project called LambdaCD, which is a toolbox for you to build your own build pipeline server. I'm working for ThoughtWorks and I'm a consultant there, which means I know the magic words. And the magic words are, it depends. So, does Jenkins suck? Does GoCD? Does your favorite tool? It depends. It depends what you're trying to do with it. It depends how good you are at doing it. It depends on where you work, what you're working on. Maybe you know everything about your tool. Maybe you know all the bits and pieces. Maybe you know the bugs. Maybe you know all its kinks. Maybe you know how to get stuff done with it. And maybe you're fine with that. And that's all right. Or maybe you've figured out how to reduce the complexity of what you're doing. Maybe you figured out how to break stuff up to a point where it isn't complex anymore. So the tools you're using are just fine for what you're trying to do. Unfortunately, I've not always been in that situation. So I've been working on those projects where there are 300 people in the room, where you have 10 teams trying to deploy onto a common platform. They all have to get stuff done. They have to get it done fast and quickly and safely. And the tools we have sometimes don't support us in that. And normally when I start talking about build pipeline tools, I go on and rant for a bit. I won't make this too long, so instead, let me ask you a few questions. And some of those are rhetorical. Let's start with Jenkins. Who of you uses Jenkins? All right. Who of you has tried getting a fork and join to work, like that radical concept that you want to build an artifact, then run a few tests in parallel, and only when those tests are green, you want to deploy? Has anyone tried to do that in Jenkins? All right, not a few. So I've tried, and don't worry, you can do that, but it's surprisingly hard. And it doesn't always end up the way you want it to do. Who of you ever broke the build trying to change the build? Yeah, and so have I. And it turns out your team isn't exactly happy when you do that. And imagine that situation with a developer. Hey, you just made changes to your code. How do you make sure it works in production? Well, I don't know. I deploy to production and see what happens. No, we don't do that, right? We test our code. We test our applications. We test them locally. We test them in test environments. Yet, we break our build all the time. And who of you tests their changes to your build pipeline before you just roll them out across all your teams? You do? Good job. But I guess most of us don't. Most of us just change stuff and then hope it works, right? And our tools don't support us well in that. Who of you tried reusing stuff? This is one of the things I always get back to when I'm in bigger projects, at some point you want to reuse, you want to introduce abstractions. And for some reason, our tools don't support us in that as well. So in the end, is that the state of the art? Yes, you can make a lot of stuff work. But it's still kind of hard, and it still doesn't work well enough. Who of you is versioning their build pipeline? You again. Some of you do. Is it version control like you know it from your programming, or is it more backup into Git? Like, okay, so can you do a blame? Can you figure out what happened to your build? Can you know what changed, or is it more you get a diff of 20 pages of XML?
No, it's in YAML, so it's not 20 pages of XML.
Okay, I got an expert here. See, shouldn't ask you all the time. All right, but still, yes, you can make that work, but still, it's kind of hard to do. And I don't think that is the state of the art we want. We figured this out in other domains, and yet in build pipelines, it's not as easy as it should be. So I started thinking, like, what would I want in my perfect tool? I have these problems mainly in big projects, in complex projects. So my perfect tool needs to support this complexity. It needs to support multiple teams. It needs to support all the bits and pieces you get across in the enterprise. So you need it to be flexible, but you also need it to be maintainable and understandable. New developer comes into your project. You want that person to figure out really quickly what your build is doing. DevOps tells us that we version everything, so version control should be a central feature. It should just straightforward work. You should be able to figure out what changed in the build. You should be able to revert it. You should figure out what is going on. As said, we have problems with complexity, and we have problems with reuse. Think about a couple of teams. They all deploy to the same infrastructure. You don't want 10 teams writing their own deployment scripts and their own deployment pipeline. You want to figure out how to reuse that stuff. So you have one tool for deployment, and you can reuse it across your build pipelines. And the new craze now, microservices. Suddenly, we're no longer just creating one build pipeline. We're spinning up new services all the time, so we need 5, 10, 20 build pipelines. And do you really want to spend days and days trying to figure out how to do a new pipeline for your new service? So setup needs to be quickly as well, and it needs to work. So with all that in mind, there is actually a good tool out there that can help us deal with all that stuff. This tool is called a programming language, right? Programming languages have long figured out how to deal with complexity, how to deal with reuse, how to deal with abstractions. And they're in text. So version control is easy, and there are tons of tools out there that can help you, from grep in the command line to full-featured IDE that can do all kinds of beautiful refactorings for you, that can do testing, that can do all kinds of crazy things. So what would happen if we actually used a normal programming language? For me, that was Clojure, to declare a build pipeline, to set up a build pipeline, to be a build pipeline. And the result of that experiment is what is now the project LambdaCD. It is a small project, and it's a toolbox. It's a toolbox that contains all the things you might want to build your own build server, in essence. So there's a really small DSL, which, this being Clojure code and Clojure being a list, is a list. It's a list of functions. There's an execution engine that can run that list of functions. And there is some persistence. There's an API. There's a UI for you to interact with your pipeline. And there are some building blocks for you, like interacting with the Git repository, executing shell scripts. You get a button to click to trigger a new build pipeline, and so on. So basically all the little pieces that I needed to build the build pipeline completely in source code. And I think this is a bit abstract, so let me show you what this looks like in practice. So let's build our own build server. So we start in a terminal. And we're using the normal Clojure build tool to get us started with the skeleton. So this created a small folder with us with a couple of files. So there's a Clojure project definition for the build tool that declares a dependency on LambdaCD and a few other small things. And there are a few source files in there. Now, as I said before, like, we have tons of tools that deal with code, so let's use one of those tools. Let's use an IDE. For me, there's IntelliJ that I use for most of my code, but you could use pretty much any IDE you like. And where is my IntelliJ? Oh, it's still starting. No. Upgraded a Clojure plugin today, and apparently you shouldn't do that before a talk. Give me a second. Try this again. Okay, let's use a different tool. Let's just use a text editor then. Sure. Anyone knows how to do that in Sublime? What was that? Command plus. I should open a file first. It doesn't work. Where is it? Command Control Plus.
One of the two plus.
Ah, here we are. All right, so it's source code, so there's a small file that is your main method. It just wires together the application. So more interesting, here, this is your pipeline. As I said, this is a list and it has a few functions, and those functions here are your build steps. And you can also run them in parallel and do a few other things. Like, so you, as a structure of your pipeline, you just have a nested list of Clojure functions. So let's look at some of the build steps. Those are your build step. This is the most basic build step you can have in LambdaCD. So the contract is that you need to take in two arguments. The one is to communicate among your build steps. The other one is to communicate with LambdaCD. Most of the time you have library functions that deal with the details of that. And the contract is that you need at least tell LambdaCD what happened. So did your build step succeed? Or you're just using one of the library functions, like in this case, we're calling the bash to run some command for us in this directory. And you can also have multiple ones and you treat the exit codes correctly. So all in all, a few lines of code. So let's see what happens when we run that code. Okay, need a bigger font. use the build tool again. So it'll take a few seconds initially to compile the project. But what it does now, it's starting up a small server for us. And here we are. So we started the application, and it's serving something on localhost port 8080. So let's see what happened there. So you can probably see this is the structure you saw before in code, but now it's in your UI, and you now have a button to click to start your pipeline. Huh, here I know how to do it. So you see, I clicked the button, started the pipeline, and some of our steps got executed. We can look at the result of those steps. We can trigger the second part of the pipeline, and we can see, okay, there's a step that failed. We can also look into more detail, figure out why it failed. Oh, it failed because, well, the exit code was 1, and that in the bash signifies something went wrong. And then there's the next build step for you, ready to start. So, going back to my slides, I hope. Somewhere in the background, I guess.
Three fingers on the trackpad, swipe up.
It sounds like a cheat code.
Okay, this is why you never change your system before a talk. Okay, I'll just get going without the slides. So, what did we just do? We just built an application. We wrote some code to build a small service for us. To do what? Well, to do what your build server normally does. We build our application, we can run our tests in there, we can deploy in there. And this is an application like any other, so you can do whatever you want to do with any other application. You can build an artifact out of it. You can run tests on it. You can run it locally, or you can deploy it into your production environment. You can do whatever you want with that. And you can put it into version control. You can treat it like any other application. And it is a full-featured build pipeline. So, what do I want you to take away from this? I want you to take away from this that you're not stuck with the tools you're currently using. There are other options out there. There are other ideas out there that you can explore. I want you to think about whether what you're currently using or what you're currently doing as your build pipeline tooling is good enough for you. And maybe it is, and that's perfectly fine. But if it isn't, here are some thoughts for you. But most importantly, I want you to take away that I want you to stop clicking around in the UI of your build tool. And I want you to start coding your pipeline. Thanks for listening. All right, questions?
Right, so the first sorry for that. The question is, how do you set up the environment around your pipeline? Because, for example, if you're going to run some tests that depend on connecting to an external service, say database, for example, how do you go around that?
Magic words again, it depends. So the question was, how do you set up the pipeline? How do you set around about the environment around your build pipeline? I would guess the same way you would do it with the Jenkins or whatever other tool you're using. So you'd probably have some way, some configuration tool, Puppet, Chef, Ansible, whatever you want, to set up the machine that you want your pipeline to run in. And you use that to set up your pipeline. or to set up your pipeline and to set up the environment you have. Yeah.
Does it support multiple build agents that run simultaneously on multiple machines? Or?
Not yet out of the box. So I haven't figured out how to exactly to do that, but it is something that you could build into the build steps you're currently using, because within those build steps you could do whatever you want. So standard way in here is a build step to call a shell script, but nothing will prevent you to create a build step that runs your shell script on another machine, or to spin up a Docker container in a Mesos cluster or something like that. So I haven't built anything yet for that use case, and it is on my list, but if you want to have it right now, you can also build it on your own. Yes?
Are you planning on replicating that shiny interface from Go.works?
I'd hope to be better, actually. But yeah, user interface is hard, especially if you're coming from backend development like I am.
Does it keep statistics, like, I don't know, builds failed in the last week or something like that?
Yes, so it keeps a history of everything that happens in the pipeline, so you can do analysis on that.
Where?
Standard way is just in a file system, so there's JSON files in the file system. There is a plugin developed from some people at the Otto Corporation, and they are using MongoDB instead as a backend, so that's also possible.
Are you using this in production, or like, how many people, companies use this already?
So I don't have exact data on who uses it. I know of at least one company that has blogged about actually using it for their teams in production for a fairly large website. And I know some of the teams in ThoughtWorks that use it internally. So it is used in production.
Could you use LambdaCD to say by the end of the build, if all the tests have passed, deploy to production?
Yes.
And so that will be also part of the project, right?
Yeah. So this is actually a more important question, like where would you put which parts of your pipeline, right? So you can put everything into Clojure code, and I've seen people do that. So you can have your whole deployment logic in Clojure code in LambdaCD. What I see more often is that people declare the structure and the parts they want to reuse in Clojure code, but they have existing build scripts in shell or something like that. And they just shell out for the interesting parts of the build pipeline, like deployment and so on. But I don't have a clear answer yet to what put into which place at the moment. Also probably depends on what kind of project you're working on.
Right. Does it support GitHub Webhooks, or is it in the roadmap?
It doesn't support webhooks yet, no. So the implementation at the moment is just Git polling, but to implement webhooks on top of that shouldn't be too hard, I guess.
Does it support manual actions? Let's say that this process stops somewhere and somebody needs to click a button so it will go forward, like for deployment, let's say.
Yes. So we've seen a simple example of that in the code. This is this manual trigger thing. Just stops until you click a button. And there's also a variant in that where a small UI pops up so you can enter parameters if that's what you want. More questions? Questions from the internet?
I can't connect to Wi-Fi.
Okay.
If we find something, we'll get you to talk about it later.
All right.
What message we're doing it?
Sorry?
There's a message we're doing this and a picture of you.
It's so context sensitive.
All right. No more questions?
Maybe
All right.
linking this to Jenkins talk initially, what are your thoughts on the future of what Jenkins talk
Wow, that's a big question. I don't know.
Put out of work with this.
Not so many yet. But if you imagine all the people who currently spend their days manually trying to configure a build pipeline, and I mean, there's even the job of a build master in some companies. Yes, you can put them out of work. Totally. Other questions?
Yeah, so I have another question. Like, how are you going to deal with secrets, like authenticating to different systems or something? Do you have any idea for that?
Probably also depends very much on what you're trying to do. So I would actually not, I guess I wouldn't deal with that myself, but I would use some other service to deal with that, like Vault from, like Vault or other secret service.
Are you building an ecosystem of plugins around this, or it's not how do you approach this?
I would hope to have a plugin ecosystem for that, yeah. So at the moment there are few plugins for that, like for example the plugin to have MongoDB storage. There's a plugin to visualize the whole thing as a CC tray XML that you can use in your build monitor. There are other plugins out there, for example, to deploy onto Marathon at the moment. So yes, it is designed in a way that you can write your own plugins for it and do that hopefully easier than the current way of, for example, building a Jenkins plugin, if any one of you has ever tried that.
Okay, big round of applause then, please.
Thank you.